Dr. Ning Ai, whose research and teaching interests focus on urban environmental planning and its integration with land use, industrial ecology, and sustainable economic development. Her previous work experiences include the application of GIS in environmental protection, urban sustainability indicators, and socioeconomic impact analysis of natural disasters. Most recently, she has been engaged in socioeconomic and spatial analysis of waste management, system analysis of urban sustainability, green transportation programs in the healthcare sector, and environmental impact assessment of transportation infrastructure. She's worked for the World Bank, the Massachusetts Bay Commuter Railroad Company, and the Georgia State Department of Natural Resources. She attained a dual bachelor degrees in environmental economics and environmental engineering in China, her master's degree in city planning from MIT, and her doctoral degree in city and regional planning from Georgia Tech. So with that, let me turn this over to Ning. Ning?
Thank you, Phil. Thank you, Stephanie. Can you hear me well?
Yes.
Great. And thank you, CUTR, for including my work for the CUTR Webcast series. And I really appreciate you all for participating. It is very encouraging to have your interest and support during this busy time before the holiday. So today I'll be discussing a tool we are developing to perform community-specific environmental impact assessment for real infrastructure. The project is funded by USDOT through the National University Rail or NURAL Center, a consortium of university transportation research centers. Funding is also provided by CN, and the project is hosted at the Urban Transportation Center at the UIC, University of Illinois Chicago. We really greatly appreciate the support from our sponsors and invite you to check out many other projects at the UTC, which is at the UIC, at the NURAL Center at the UIUC, as well as CUTR at the USF. So this is the outline of my presentation today. First, I'll give a brief overview of this project and some background information and the challenges about real infrastructure in Illinois. Then I'll explain our research methodology and the procedures of research. Most of the time, I'll focus on our research results, including the metrics, environmental models, and the web mapping tool. I'll conclude with our challenges, future research, and questions that I will particularly appreciate your input. Here is a very brief overview of the project. As you are participating in this webcast, you are very likely well aware of the lengthy and expensive process of environmental impact assessment, especially involved in NEPA. An overview of environmental impact available early in the stage when opportunities of multi-agency coordination can be identified and the public can be informed, the environmentally sensitive areas and the socially vulnerable communities can be addressed. This project aims to increase the effectiveness and efficiency of environmental impact assessment of real infrastructure. They are aligned with the goals at the USDOT strategic plan, especially in terms of safety, environmental sustainability, equity, and the livable communities. While many transportation GIS databases are commonly available, including those actually in Florida, they are the front runners apparently, and environmental GIS databases in particular tailored for real infrastructure actually have been very limited. Recent audit, if you have, hello, can you still hear me? Somehow it sounds like I was dropped.
Yeah, we can still hear you. You're fine.
Great, great. Okay. As you may have noticed, the recent audit by the DOT Office of Inspector General concluded that the existing NEPA procedures at the Federal Railroad Administration are outdated and limited double codes, and thus recommended an update of its NEPA procedure to reflect current environmental laws and regulations. So, in addition to overlaying data layers in a one-stop GIS database for real, as we have commonly seen in other places, this project also aims to provide references for refined geographic scales, such as neighborhood, grid crossing points, or any user-specified area, meaning irregular area as well. Besides myself, 4 graduate students have greatly assisted contributed to this project. Marcella and Anthony are from urban planning, Shaw and Sheen are from computer science, and they are helping with the web design. Their outstanding performance actually can be evidenced by their job placement right after graduation from UIC. At this moment, it may help to discuss a little bit about the timeline of the project as well. We actually officially started in 2011 in winter. So the framework of sustainability metrics and data collection process, as I will discuss shortly, will basically complete it within a year. But continuous development in legislation and the feedback from professionals just like you have motivated us to continuously update the metrics, the data, and the website. However, the reality is the research funding has a relatively limited time frame, but this research does require continuous funding in terms of data maintenance, updates, even including the web server host. Currently, we are paying a monthly fee to UIC, the university, to have this website alive. So after I talk through our current research today, if you see any potential relevance to your work, if you see any additional data or alternative designs of the tools could better assist your work, we really, really appreciate your suggestions and comments. Any feedback you could provide us. They are really critical for our application of additional funding to keep this tool available and up to date if it is available to you all. All right, so just a clarification of the expected use of the tool I'm going to present today. We expect this tool can be used to identify high priority and sensitive areas for sustainable rural planning and management in Illinois. Rather than providing precise data for engineering studies, it is actually designed to facilitate a rapid assessment before a formal NEPA process is initiated or implemented. It may also have a facilitate coordination between rural planning and operations departments, multiple departments in particular. In addition, the results of the research will be accessible to the general public and the researchers who are concerned about environmental impact, community development, and social justice related to rural infrastructure in Illinois. So in all, we expect this tool will be valuable to not only transportation professionals, but also general and the citizens. All right, for those of you who are out of the Chicago, Illinois region, some background information about the rail in Chicago might help. The first rail line was built in Chicago in 1836. Today, Illinois is home to one of the largest railroad networks in the U.S. with over 7,000 miles of freight rail tracks. Overall, rail tonnage is forecasted to increase more than 60% between 2007 and 2040, largely due to the growth of intermodal container movement. The figure to the left on this slide depicts the rail traffic in Chicago region and Illinois. The most heavily traveled rail track segments are located on east-west rail lines near Chicago and St. Louis. The rail planning process is also complicated by the fact that the system is operated by 41 different companies. 50% of all U.S. rail freight passes through the Chicago region. The region is also the focus of two new high-speed rail projects for intercity passenger transportation. As the rail hub for the nation, the region's rail transportation is also challenged by traffic congestion, as you can imagine here on the map, and the land use conflicts. Nearly 2,000 grid crossings between railroad tracks and the roads slow down automobile traffic and present risks for collision between trains and automobiles. Traffic congestion is worsened when freight trains and the passenger trains share right away on railroad tracks, especially when it involves multi-ownership, as you can tell from the figure on your right, when each different color represents a different company that owns the tracks. Furthermore, the complexity of the rail system creates air quality and health concerns. So the trains themselves may not produce high levels of air pollution, but what really matters is the size of heavy rail activities such as rail yards, intermodal terminals. They are the major contributors to air pollution. Given those complexity of impact, compliance with federal statutes and regulations are required for all federal and federal-assisted rail projects. DOT required each transportation agency adopt procedures and rules to implement federal laws for projects within each agency. FRA implements programs to implement rail safety. FTA implements programs for public transit agencies. State of Illinois and Illinois DOT also have adopted additional statutes, regulations, and guidance. These laws and regulations address civil rights, environmental policy and resources, cultural resources, pollution, health, and safety issues. So the list of legislation I list here on this slide actually only represents a partial list. Given this complexity, it is evident it can be very difficult for transportation professionals and environmental planners to have a full understanding of the overall system performance and impact, particularly early on the planning process. This chart shows our general framework of research methodology and the procedures. So first, we resort to research literature, pertinent regulations, and international best practices for the metric development. And then, based on the metrics, we identify the data needs, and we identified and collected the data needed to complete the sustainability assessment. In terms of environmental models, we look into operation infrastructure. The areas I marked in gray actually are those we targeted to capture, but still haven't completed due to data constraints. We further collected data in terms of background information of the communities, natural habitats, hazard areas, those environmental sensitive land areas, and then integrate them in a geographic information system, GIS database. The GIS database includes real operations, infrastructure, and maintenance data as well, and also including the base layer data. And finally, we developed a web tool that will allow users to access the GIS database and sustainability metrics, and also allow users to specify a geographic area of interest by drawing online and extract data for their customized area. This research currently is limited to the scope of Illinois, but we believe the generic framework could be replicable in other regions. Okay, here's an overview of the sustainability metrics framework. Those metrics were developed to align with the U.S. regulations, the NEPA process, and the Illinois legislation and the statutes and the tools such as ILAST, which is a sustainability rating system for roadways. Separate metrics have been developed for transit rail, commuter passenger rail, and freight rail. For example, we considered distinct needs and goals for different rail systems. Freight rail metrics focus more on the safety and economic competitiveness, but less on accessibility, which is a major component for transit and commuter passenger rail. And for the metrics per se, we've tried to focus on performance standards. Ideally, performance standards will be the result of the outcome. For example, when we consider the number of ISMA cases, the output will be the pounds of the particular matter emitted. So there is a difference between the performance indicators and output indicators. The checklist of the metrics we developed also are broken into spatial and non-spatial metrics. The spatial metrics are visualized on the tool's interactive map online. The non-spatial goals are captured on the sustainability checklist, which we have it in the Excel table, but they are not represented on a GIS map. The checklist can be used through a tiered approach that specifies meeting minimum regulatory requirements or best practice sustainable alternative. For example, Tier 1 typically required by regulations are commonly assess the impact. Tier 2 are rather advanced less commonly evaluated in Illinois, but used in other states or countries, especially in Europe, and recommended as part of an enhanced sustainability program. So we have been also collecting benchmarking data associated with these metrics. When data available, the benchmark data is for a national average or regional comparison. When data not available, we chose the best practice standards identified from government guidance or academic literature. So in the next few slides, I'll present the sustainability metrics specifically for transit rail only. As explained earlier, we developed a separate set of metrics for transit rail, freight, and passenger commuter rail because these three represent very distinctly different system goals for the brevity and given the time constraints, I thought I would just focus on one because these three sets of metrics do share common categories and similar metrics. If you have additional comments or questions, feel free to email me after this webcast. Okay, starting Tier 1 special indicators. Again, so we separate into Tier 1, Tier 2, special, and non-special. I'll go through them one by one. So for Tier 1 special indicators, you may notice that all the metrics are quantitative measures, such as the injury rate, acres of environmentally sensitive land. And then you could also see the legislation or guidance or academic research that in particular support this type of metrics. You all should have access to the full slides after the webcast, so I will try to be brief here instead of reading them through one by one. This slide shows more Tier 1 special indicators focusing on equitable and affordable transit services, environmental justice, protection of natural landscapes, and community resources. The next slide is on Tier 1 non-special indicators. Again, these metrics and data are not included currently in our GIS database, but they basically serve a guideline or checklist for the planning process. These specific metrics include the traffic congestion, the travel mode share, economic investment and development, community support, wetlands and critical habitat, hazardous waste and noise, and others. And continue here on this slide. Again, you could check the full slide information afterwards. And last set of the metrics for Tier 2. Tier 2 metrics, again, for higher level sustainability goals. These metrics include the mode shift analysis and the project-specific impacts, such as the microclimate, site hydrology, life cycle waste, and energy uses. And those are the non-special indicators for Tier 2. At this moment, I want to add that we presented this initial set of metrics to a focus group of experts on transportation planning, especially in terms of rail planning. And they give us great suggestions and very constructive comments. And one of the controversial issues is weighting and integrating multiple categories of the metrics. We initially designed to develop a scorecard of sustainable rail transportation network. However, given the controversial comments at the focus group meeting, we decided at this moment to keep the metrics as a standalone metric set instead of integrating or weighting them. It may help to add the key arguments of not integrating or weighting the metrics is practitioners hope to find specific policy relevance after they refer to the metrics. And if we arbitrarily integrate the metrics, and they may lose the implicit or direct policy implications out of this evaluation process. So that's why we decided to keep the metrics as it is. This slide gives you an illustration how we connect the metrics with the spatial mapping tool. So given the data needs and standards compiled in the sustainability metrics, we collected the data then for the data, there are different levels. One is the base data layers. Those are the data that we directly retrieved, accessed, downloaded from agencies such as the U.S. Census, USGS, Illinois DNR, FRA, FTA, DOT, as well as other agencies. And then based on those base data layers, we developed models for local specific data. In this presentation, I'll focus on one location-specific model for air emissions. This slide shows you the steps and the methods we use for emission estimate. The figure or the flow chart to the left shows our three-step process. So first, we use the weighted metric to identify hotspots, meaning the priority areas for assessment based on the number of trains, train speed, line haul versus switching operations at various segments in the rail network. Then the result is the map to the right, the hotspot map. The darker color shows the regions that shows a cluster of high emission areas. And then we refer to these hotspot areas. We have a closer look, and then we develop the location-specific models. The location-specific models integrate the grid crossing data, because at each grid crossing, that's where we can find the data in terms of traffic count, traffic speed, and we have a freight focus. We retrieve the data in terms of freight tonnage and carloads. We retrieve the data from fuel efficiency, from EPA, and emission factors. So those are the factors we incorporated into the location-specific area emission modeling associated with grid crossing locations. And the grid crossing locations will further join to tabular train operation data and area emission factors. And the next step, we spatially analyze the impact of air quality on people by overlaying the pollution dispersion results with land use and demographic data. The map shown here gives you an example of emission estimates from freight rail for a particular matter only. We also included results for carbon, NOx, and other criteria pollutants. This slide shows you the overlay results of the emission impact and land use and community status. So, as shown here, Chicago's west and the south neighborhoods show significant burden of emissions on very low-income populations. The low-income populations on the map to the left are illustrated with lighter color, basically nearly white. The darker the color, the higher income is represented in the neighborhood. And it also indicates the need for further study in these locations to evaluate environmental justice concerns. So our potential next steps for the air emission model will include connecting fuel emissions to air quality impact by incorporating meteorological and topographic data into a pollution dispersion model, meaning to connect the emission level to a concentration level. A further question to be addressed is the connection between air quality and the human health risk. In other words, further studies are still needed to translate the emissions as an output metric to a performance outcome or impact factor. All right, so here comes to the exciting part, the web mapping tool. It is publicly accessible for everyone at newrail.usc.edu. It is free to everybody. Users can customize the user data for display. They can customize the study area, either by hand-drawn points, multi-points, a line, or area on the map. You can choose a buffer area, basically, to examine data or the environmental information, not only for the area you specify, but also a zone from a certain distance of the center of the area you specify. And then after you specify the area, you could retrieve summary data of interest in the selected areas. This is the main web interface. As you can see here, we have included multiple data layers, and if you click on the plus mark, you could see additional subcategories of data under, for example, real infrastructure, community profile, safety, livable communities, transit equity, and environmental sustainability. And I want to also alert you to some of the buttons to the right. Actually, we're still developing, but we are testing the value of those buttons. First is the switch base map. This basically showing a different base map. You could choose to use Google Maps, and you could choose to have a busier map that will also involve more information. We are adding help documentation. This should come on the way very soon. And the button to the right, on the right-hand corner, clear map, proves to me as a very useful tool. Sometimes after we draw an area, and then we may change our mind, or you may want to draw another area, and that's a place you could clear the map and start from the beginning one more time. And sometimes there are glitches of the website. Somehow the Explorer, i.e. Firefox or Safari, may not always work every time, and clear the map or even restart the Explorer may help solve most of the issues. Okay, here I'll give you two examples, starting with the first one, for example, just to identify acreage of environmental sensitive land to be affected by a proposed corridor. Okay, so for simplicity, let's say we'll just choose one category of the data here in terms of the habitat. So under the habitat category, we got bird presence, critical habitat, natural area, and riparian zone. And then you check on the box next to the data layer. That's what environmental planners may be particularly interested in. And the next step, you can hand draw a corridor, a line. And notice to your left, there are different options. There are points. There are multi-point, line, polygon, freehand polyline, polygon, freehand polygon. So there are different options. In this case, we could use a freehand polyline, which means you could hand draw a line like I have here, the red line here. It's just completely hypothetical case, assuming you were wondering why we haven't got a circle type of real network, given kind of the radius of the existing real network here. The next step, you could specify a buffer distance. Here, I have assumed that it will be 3, meaning 3 miles outside the line we have just drawn here, hypothetical case. So we are assuming a 3-mile buffer zone. And then the next step, you could see the data. Right now we have reduced the number of decimals of the selected area, but you could see the total acreage or kilometers of the area and the buffer area, and also the different categories of the environmental sensitive areas, including their acreage. So this gives you kind of a general idea of the potential impacted land of a proposed area. Now again, this is just for a rapid assessment. That doesn't mean you'll get 2 digits, decimals in terms of the accuracy, but at least gives you a general idea whether it will generate potentially significant impact on environmental land. So the next example is really something that does not require a lot of environmental understanding or knowledge of the impact of real infrastructure. Assuming just for general public, they are concerned about the potential impact associated with the real infrastructure and the traffic in their neighborhood. So again, we go back to the homepage of the website, and assuming users will choose to view the data related to real infrastructure. That includes intermodal terminal, grid crossing, public transit facilities, railroad speed, and here I added a legend for the rail speed. Basically, the higher the speed of the maximum rail speed that is allowed on that segment, then the green color shown on the map. Basically, this map tries to highlight areas with relatively slow rail traffic and which typically associated with greater environmental impact. So the next step, this time we'll try to use a polygon here. Basically, you hand-draw an area, as I have shown in the blue area here on the map. Again, it's completely hypothetical and just for demonstration purpose only. Okay, and then next step, we will move on to the buffer analysis. And this time, since you already drawn an area, and basically you assume this is big enough for your analysis, so you choose not to add any buffers to this area. So you just choose no, go to the next step. And then you could retrieve the summary data in terms of the area of the hand-drawn area you just specified on the map, and CTA transit services that this neighborhood may be served, the railroad speed, again, maximum speed that is allowed in this area, and the grid crossing information. Note here, the grid crossing data layer also includes some additional information people may be interested in. For example, day through train and night through train here, and also the estimated percentage of trucks and type of development associated with the land use pattern. So these two examples give you a kind of a general idea of how these maps and the tools might be useful for both transportation professionals and the general public for rapid assessment of the environmental impacts associated with the rail infrastructure. All right, so here I will quickly sum up this research. I will iterate that we hope this project could help streamline the rail planning process and provide a reference for pre-NEPA review process. It could facilitate the coordination within rail agencies. Additional data from other agencies could be easily added to the GIS mapping tool, and essentially could help all agencies assess the data in a one-stop database. We also hope this could advance the rail research in terms of location-specific modeling, as we show here in terms of the air emission data associated with each grid crossing, which is a much smaller and refined scale compared to many other existing emission modeling tools. And I also hope this tool will be readily available to help engage the public, to educate the public, to increase their awareness of the potential impact of the rail infrastructure. I would also like to highlight a few challenges we have come across. We hope in the future this could help provide project-specific information, meaning two-way communications. We hope to allow users to input data information as well, so that it could be integrated with data and generate project-specific impacts for meaningful policy analysis. We really hoped we could capture noise impact in this study. However, we were not very successful in gathering the field data. This is something we still have a strong interest in, and if any of you have any references or additional information, any suggestions or comments, we'll really appreciate. Given the high density of grid crossings in the Illinois region, especially in urban areas in Chicago, noise has been a major concern. We will assume this will be a very valuable and useful information for this tool. However, we were not able to integrate the real or field data of noise information into this web tool. We could theoretically model noise data. Apparently, it would be nice to find the data, real data, to validate our models and analysis. And again, I cannot emphasize more in terms of the importance of data maintenance. Apparently, data will be only meaningful and useful when they are up to date. However, we do have seen challenges both in terms of technical help and also in terms of infrastructure, in terms of the web server host and the university to maintain the website, to update the website, and then keep it up to date, especially in correspondence to the evolving legislation and the evolving literature in the research. So any of your suggestions and comments are particularly appreciated and helpful. Here, I want to add, we really appreciate the comments and suggestions of these people. Each one of them will help us at the focus group meeting and help us collect the data that have made this web tool accessible and available to the public as a free tool. So I think I'll stop here and try to leave ample time for questions and comments. And thank you so much for your interest. And I'll be ready to address your comments. Thank you.
Great. Thank you, Ning. Thanks for a very interesting presentation. So you can see on the screen right now, if you have a question, you click on the Q&A in the upper left-hand corner of your screen where it says Q&A, type in your question, and then click the word Ask, and then that will provide the list to myself and others, so we'll address each of those questions. Actually, I had a couple to kind of get us started as well, and in picking up, Ning, on the last comment about the data quality, how often do you see the data in this tool will be updated, and who will be doing it?
So we started in 2011, and since then we have been continuously updating the data and updating the metrics as often as possible. For graduate students have greatly helped on that. However, we officially do need to wrap up the project, and after that we will not have like either full-time or part-time staff. Basically, I myself may keep an eye on it, but very limited resources. That's why I emphasize the importance of data importance, and appreciate your comments and input. And one possibility we have considered is if this type of tool will be of interest to either transportation agency, if they will help them engage the public and increase the public awareness. We hope this could be potentially integrated as a part of the existing transportation databases. It could also be of interest to nonprofit agencies and organizations, for example, if they would like to help engage the public and advocate for the public, because it is free. So in the long run, I hope that this will be the solution for long-term maintenance.
All right. Well, in the other part of kind of that question, I think you've shown that basically the data and the maps only cover Illinois. What are the challenges or opportunities if you were able to replicate this in either nearby states or in other regions of the country?
That's a good question, and I'm glad to see the interest in other regions. So this database is indeed for Illinois only. However, when we collect the data, most of the data sets actually of national scope. So we, for efficiency purpose, intentionally only select the data out of those data sets for Illinois. So for environmental data in particular, most of them actually have data available for other regions in the state. For transportation data sets, it could be region-specific or location-specific, but basically the framework is generic. And personally, I do not perceive a time-consuming process to include all, although it may be time-consuming to validate the data, to eye-check the data, make sure things are up to date and represent the most accurate information that we can gather.
All right. Great. And I think you've talked about like one potential use of the research is for pre-NEPA review. Do you have any other examples or insight of how else it might be able to be used?
Well, I personally feel very excited because Chicago is the home to potential high-speed rail projects, and more projects may come up. And in this process, I think there will be several layers. For example, to help engage the public, and this is a tool that will be potentially helpful at the public meetings, for example, before or after the public meetings. So it does not require a lengthy process to produce the results of the potential environmental impact. I also want to add that most of the environmental impact assessment, especially those formal environmental impact assessments, are triggered by the NEPA regulation, which only apply to those projects that are federally funded. But increasingly, transportation projects, especially rail projects, funded or initiated or planned by private companies. And in that case, the environmental information or environmental impact of potential projects may not be mandated to be publicly accessible or available. So in this case, I think this tool will potentially help the public better understand the project regardless of the sponsor of the project, regardless of the scope or the scale of the project. It could be as small as a few segments, for example, like rail track upgrade. For example, it could be multiple region card projects, and that will easily help them rapidly assess the potential impact. So that's one way that I think will potentially help. Another way is for multiple agency coordination, and at this moment, I mentioned this earlier in my presentation. Multi-agencies are involved maybe involved in the process, but each agency is required by DOT to develop their own regulations and standards. So it's inevitable there could be inconsistency in terms of the goals, in terms of the agenda, in terms of the specific timeline. And this tool may potentially help multi-agencies to coordinate with each other to help them identify the inefficiency, inconsistency in the process. And I do also hope they will incorporate the concerns of social justice or environmental justice into their planning process so that this can be avoided in the early planning stage. And I need to add that this may not be a priority concern and often considered in the current real projects. Would that help in some ways?
Yes, definitely. Well, I appreciate that. And now somebody's asked a question that in many communities across the nation, including Chicago, they're concerned about the shipment of crude oil via freight trains due to heightened domestic production. Do you think this research and mapping tool of yours will provide any additional insight that might help prevent an accident?
Yes and no. Technically, it probably will not be preventing an accident because it's rather engineering design process. But I would say it will help in terms of the infrastructure planning process because the tool itself does identify the priority areas and identify the high traffic areas, identify the areas with the neighborhood, with surrounding neighborhoods that may be sensitive to high traffic and potential environmental hazards and spills. So in the long-term planning process, the tool may help the communities identify the communities, I mean the professional community and the general public as well, to help them identify the high-risk areas so that they could try to avoid when they plan for the routes of crude oil shipment, for example. And also, it could help them identify the risks of accidents. Here, I didn't elaborate on that because I mostly focus on emission model estimates. But in terms of the accident risks, UIUC, which is also the home of the New Rail Center, has a lot of expertise area in terms of the risk assessment. So we refer to their model in terms of derailment and the safety concerns, and then plug in our data and estimate the risks associated with segments of the rail tracks. So if we could collaborate like that, then essentially I think it will potentially help reduce the risks of such accidents. I would say, to be accurate, not exactly prevent an accident, but to reduce the risks of the accident.
I see. Okay. Basically, I've got I think we're like one more question in the queue, but anybody else has any other ones, please feel free to continue to submit through the Q&A. I guess given what you know today, if you had to do this all over again, what might you do differently than you've done to this point?
Oh, that's a great question. What if? So I would definitely involve practitioners and focus groups even earlier in the process of the research, because we basically presented our research results last winter when we were about to kind of complete the most of the framework, and turned out they give us a lot of constructive and great common suggestions, which made us redevelop the metrics, for example. And initially, we developed the metrics based on different phase of the infrastructure planning project. For example, design process, operation process, maintenance process, emergency response process. And then we have all the metrics for the entire rail system. So we obtained great insights at the focus group meeting. That's why we revised it and completely reorganized the metrics by the rail system. And even today, when I reflect on it, I still think having a matrix or having a database for all the rail system could be still too big. We still need to refine the system and refine the tools. Although we would like to cover each of the rail system, commuter passenger rail, transit rail, passenger rail, likely each tool and each system is needed for their specific needs. So we may not want to integrate everything into one, but rather develop one for each to address their unique needs and goals. So that's on top of my mind.
If one other question has since come in, is that the question is, have you looked into applying these methods in your native China?
Wow, that would be really exciting. So the spatial data in China could be sensitive. The models are sophisticated in many ways. I'll be frankly just adding to the research area that many Chinese scholars models in terms of location-specific modeling will be advanced. But to have something freely, readily accessible to the general public could be a challenge because of the cultural or political system there. More and more data are becoming more transparent in China, and that's really a positive sign. However, to have all the information, especially when we are talking about refined scale data, that could be a challenge. If it is rather crude level of analysis, I will say, yeah, definitely. But if we are thinking about, for example, at the beginning of this project, we actually added the function on that mapping tool. Users can specify address of any street address with a street number. I don't think that type of refined information will be accessible, will be allowed to be disclosed to everybody around the world, given the context in China. But if we're thinking about a parcel or more like larger size of the neighborhood or kind of small cities, then that's definitely doable. It is not technically difficult.
Yeah, okay. On that note, I'd like to thank you, Ning, for your great presentation. And if for those folks that have attended, we'd ask you to take a minute to just complete the evaluation. And let us know how if you have any questions or comments, and feedback you'd like to provide to Ning or to us. And on behalf of the Center for Urban Transportation Research here at the University of South Florida, this is our, as Stephanie indicated earlier, this is our last webinar of the year. So we'd like to thank you for attending and have a happy holiday, and we'll see you back here in January. So long.